All right, let's take a look at this lesson on solving radical equations. Ooh, that sounds like fun. So first of all, what is a radical equation? Okay, it's one with a root. Now, this is an example of a square root. Certainly, we know there are different kinds of roots, cubed roots, etc. So it would have some type of root. So the very first thing that you would do, our first step, would be to get the radical by itself, isolate it. If you happen to have more than one, ooh, then you're lucky, right? If you happen to have more than one, then you want to put them on different sides of the equation. Okay, so these are just our guidelines. This is what we would do. The second step, so our step number 2, once we get isolated, we're going to raise both sides of the equation to whatever power will eliminate the radical. And that might sound kind of weird right now, but we'll work through it and we'll explain what that means. And the last step is to check for extraneous roots. Now, why would we need to do this? Why would we need to check? When we have an equation that we do something like we square both sides or, things like that, it can generate extra answers that aren't actually true answers. So because of the result of doing that, of like squaring both sides or cubing both sides, it's certainly possible that we could get some answers that aren't actually answers. And that's why it would be really important for us to check for extraneous roots, check for extra answers that really aren't answers. And so as we go through this process, I'll show you how to do all of that stuff. So first, let's work on a fairly simple one. We're going to do step number 1. We're going to isolate the radical. Okay, so that would give us, we would add the 2 over, so the cubed root of x equals 2. So now we would be on step 2. We want to raise each side to whatever power would get rid of the radical. Now maybe it's hard to see when it's in radical form, so let's change it to exponential form and see if it's more obvious what I need to raise each side to. So I'd have to ask myself, what would I multiply 1/3 by to get 1? Because I want x to the first power, right? That's what we want. So I would simply raise it to the 3rd power, because we know 3 over 3 is 1. And that would give me x is 2 times 2 is 4, 4 times 2 is 8, x is 8. All right, so that's our answer. So let's do a little check out here. And you don't have to show me, you don't have to write the check out. It just, again, is a good idea for you to double check. So we're going to plug the answer we got right back into the original equation and see if this is true. Is the cubed root of 8 minus 2 0? Let's see. So the cubed root of 8, we would do a factor tree on it. If you don't know what the cubed root of 8 is already, we have a group of 3. So this would give 3 2's, so it would give me 2 minus 2, which is 0, so it does check. This is, in fact, an answer. Yay, that's not too bad, right? All right, so let's look at our second problem. This one is already written in exponential form, and so it's already isolated, so great. Step 1 is done for us. Now our job is to figure out what should we raise each side to. Let's see, what would I multiply 3/2 by to get 1? Yeah, you're right, you would multiply by the reciprocal. If I raise each side to the 2/3 power, then so let's check that out. So 3 times 2 is 6, and 2 times 3 is 6, and we know 6 over 6 is 1, is 27 to the 2/3. Now, we might want to put this number in radical form, so maybe that will help us, the 27, help us understand what to do. So I have x equals, let's see, so this, or just a reminder, remember this bottom, the denominator, is what kind of root we have. So this is the cubed root of 27, and that is squared. Okay, so we do a factor tree. Let's see, what is that? That's, let's see, so that's 9 times 3, 3 times 3, okay, got a group of 3. So then that gives me, we know the cubed root of 27 is 3, and then we square that and we get 9. All right, so let's see if that works. So let's check it. Okay, so I've got 9 to the 3/2. Does that equal 27? Okay, so let's put it in radical form. This 2 is the kind of root, so that would be the square root of 9 cubed. Does that equal 27? Let's see, so we know square root of 9 is 3, and 3 cubed, well, 3 cubed does in fact equal 27. So yay, another correct answer. All right, great. Hopefully we're catching getting the hang of that. So let's go on to the second page where they get a little bit more complicated, just a little bit more. So we're still going to follow that same premise. We're going to isolate the radical. So we've got the square root of 3x minus 8. I'm going to move the 1 over, so I subtract 1 from both sides and I get 2. So square roots, we're probably okay. Are we okay without transforming it into an exponential? We know that the square root would be like 3x minus 8 to the 1/2. Why not? Let's just do it. That would be fun. So to the 1/2. So what would I raise 1/2 to get a 1? So I would raise each side to the second power. I would square each one. That would give me 3x minus 8 is 4. So now that's just a regular old equation that we've been doing for years, right? So I'd add 8 over, and that gives me 12. And then I divide by 3, and that gives me a 4. So let's see, is that a legitimate answer? Let's do a little check over here. So I'm going to take the 4, and I'm going to put it in the original problem in place of the x, and see if that's true. Okay, let's see, is that true? So let's see, 3 times 4 is 12. 12 minus 8 is what, 4? Let's see, the square root of 4 is 2. Okay, so yes, it is legit. That is a good answer. Okay, great. All right, let's look at number 4. Well, it's already isolated. Hopefully we're okay with the square root. That's like to the 1/2. So we would raise both sides to the second power. So that gives me 7x minus 12 equals x squared. Oh, looky here, probably another opportunity for us to factor. Yay! Okay, so I like keeping the x squared term positive, so I'm going to move all the other terms over. So x squared minus 7x plus 12 equals 0. Great, 3 terms, factor like FOIL. Hopefully remember all that. The back sign is positive. The front sign is negative, so that means they both have to be negative. Let's see, so we're looking for 2 numbers that multiply to get 12 and add to get 7. Let's see, that's a 3 and a 4. And so let's see, so we would have x equals 3 and x equals 4. All right, great. Now I will tell you that I have already checked these. I hope you're getting used to the checking part. I have already checked these, so I'm just they are the actual answers, but just for time's sake on the video, you would go ahead and check both of them and see if they work properly. All right, so let's look at number 5. Oh, isn't that so fun? All my candy canes. Memories of Christmas. So I need to get rid of the 3/2, so I want to raise each side to the reciprocal, because we know 6 over 6 is 1, so I have x plus 1 equals 8 to the 2/3. Okay, so let's go ahead and write that in radical form, just so it's a little easier for us to deal with. This is the cubed root of 8 squared. All right, so let's see, that's 4 times 2, 2 times 2. I've got a group of 3, which is what I'm looking for. So that gives me x plus 1 equals 2 squared. So x plus 1 equals 4. And then I move the 1 over and I get x is 3. And I have checked this one as well. This one is correct. Great, how we doing? Okay, so we have a couple more problems to work with. Of course, they're going to get more and more fun as we go along. Number 6, we want to isolate the radical, so I want to move the x over. So I've got, and I'm just going to put this in exponential form, just for fun. Do you have to do that? No, absolutely not. I'm going to move the x over, so I have x plus 1. Okay, so let's see, what would I raise each side to get rid of the 1/3? I would raise each side to the 3rd power, because we know 3 over 3 is 1. And I have x plus 1 equals, oh yes, you are right. I'm going to have to multiply all those little guys out. I have 3 of them. Ooh, that looks like fun. Okay, we can do this. So x plus 1 equals, I'm going to do the first, I'm going to work on these first two, multiplying them together first. So foiling, right? X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. Now that we're going to multiply by x plus 1. Okay, so let's work on that. Let's combine these two together. These two together are going to be 2x, right? X plus x is 2x. Okay, here we go. So I've got x squared times x is x cubed. X squared times 1 is x squared. Then I have 2x times x is 2x squared. 2x times 1 is 2x. Then I have 1 times x is x, and 1 times 1 is 1. Whew, okay. Let's clean that up. Okay, let's clean that up. So I've got an x cubed. Let's see, what is that? Plus 3x squared plus 3x plus 1. Okay, and you're thinking, oh my goodness, what are we going to do? Well, we're going to have to move everything to one side and try to factor. Ooh, that looks fun. So I, again, prefer to keep the biggest exponent, the leading coefficient, positive. I don't really like dealing with the negative ones. So I'm going to move these two guys over to the right. All right, so I've got x cubed plus 3x squared. Let's see, 3x minus x gives me, what, 2x? And then I move the 1 over. 1 minus 1 is 0, so that's what I have. So if you recall our rules for factoring, we want to try to find a greatest common factor first, a GCF. X would be my GCF. And so let's factor an x out. Okay, fantastic. So now I have 3 terms. I want to factor like FOIL. So what do we have? Let's see, the back sign is positive and the front sign is positive, so they're both positive. Well, there's really only one way to get 2. It's 2 times 1. Let's see if that works. 2 times 1 is 2, yep, and 2 plus 1 is 3, so very good. So our answers would be x equals 0, x equals -2, and x equals -1. And I have already checked those, and they are all good to go. All right, that takes us to our very last problem. Oh, it's a crazy one. I have 2 radicals, and the instructions said if I have 2, I need to move 1 over. So I'm going to leave the square root of 2x minus 2 over here, and then I'm going to move the square root of x plus 6 over, just so I can, I like things that are positive. That just makes my life easier. Now I'm going to square both sides. Okay, so the square root of 2x minus 2 squared is just 2x minus 2. And yes, we're going to have to FOIL that out. It might be easier if I wrote this out so you can kind of visualize what I'm doing when I'm FOILing. Okay, so I have 2 of them, so I just wrote them. So 1 times 1 is 1. 1 times root x plus 6 is root x plus 6. 1 times root x plus 6 is root x plus 6. And root x plus 6 times root x plus 6 is x plus 6. Whew, okay. So we have generated, still got a radical, so we're going to have to isolate it. So let's work on getting it by itself. Okay, so I'm going to add those radicals together, and that gives me 2 square root of x plus 6. And then I'm going to move these guys right here over to the other side so that I can have that, radical by itself. That's what I want. So I have 2x minus x gives me, what, x, and negative 2 minus 1 minus 6. Let's see, what would that be? 6, 7. That would be a negative 9. Okay, here we go. So now we're going to do that squaring both sides thing. We got to get rid of the radical. So this is going to be foiling, right? So it would be x minus 9 times x minus 9 equals, we're going to have to FOIL that out. 2 squared is 4, and the square root of x plus 6 squared is just x plus 6. Yay, the radical is gone. Now we just have some algebra to do. So let's FOIL this out. So I've got x squared minus 9x plus 81 equals 4x plus 24. Okay, very good. So moving everything to the left side, that's going to give me x squared. Let's see, minus 9x is minus a negative 18x. Minus 4 gives me a negative 22x. Then I have 81 minus 24 is 57. And we think, oh my goodness, that is just weird. But strangely enough, it does factor. Okay, the back sign is positive, so my signs are the same. They're both negative. And 19 times 3 is 57. And 19 plus 3 is 22, so we are good. So I have x is 19 and x is 3. Now I did check these, and one of them does not work. So let's go ahead and check. We're going to check, well, I already know which one doesn't work, so I'm just going to demonstrate how I know it doesn't work. So we're going to check the 3. So I've got, here's my check. Okay. So I've got the square root of 2 times 3 minus 2 minus the square root of 3 plus 6 equals, does it equal 1? Okay, so let's see, 6 minus 2, that's the square root of 4. 6 plus 3 is 9. Does that equal 1? So I've got 2 minus 3. Does that equal 1? No, it equals negative 1. So this is not an answer, and this is the only answer. All right.